So, good day again, everyone. Today we're going to be discussing, I'm going to explain to you about Eplan2C. So, as always, you can find the Eplan2C in your Moodle. Specifically now in midterm week 2, you can see the Eplan2C and download it accordingly. So, the learning outcomes for this style is to determine the true course and true bearing. The E-plan is as well in conjunction with that objective. So let's download the Eplan2C. So this is Eplan2C. So again, you need to download it, print it, and read it carefully and prepare the materials. I trust that you already have these materials because it's just the same with the previous exercise. Also read carefully the performance criteria because this is what I'm going to be needing on your end. And the most important part, the scenario description. So at 1200, the vessel is in the vicinity of Lagunoy Gulf with visual observation using the magnetic compass. The OOW observed Sialat Point and Aguho Point in transit, which bores 345 PSE per ship's compass. So, uh, given that data, we download the chart number 1. You can always find the chart number 1 here in your previous e-plans, or you can download here in chart. So anyway, this is the downloaded chart number 1. So this is the Lagunoy Gulf as mentioned, and this is the Sialat and Aguno Point. You can see here, Sialat and Aguno Point. So it says here that at 1200, the OOW observed in transit with a bearing PSC of 345 degrees. So we measure 345. So in Sialat Point and Aguno Point here. So again, as per usual e-plans, you need to always mark anything you put in chart. For example, in this case, you should mark 345 PSC and 1200. In this demo, I will not be doing so, but in your end, you should always mark what you put in your charts as per international annotation. Okay, going back, so this is 345 in transit with Sialat Point and Aguno Point. So in transit meaning they have almost the same, or they are almost, these 2 points are almost aligned. Okay, so let's go back to the E-plan. So the first performance criteria is calculate the variation. So we calculate the variation. So almost it's actually the same as what you did in E-plan, in your previous E-plan, where you calculated the variation. Needless to say, you can find the variation data here in the compass rose. So quick recap, the variation is 1 degrees 15 minutes west at 2013. Since we are already 2020, so these 2 minutes should be multiplied by 7, because 2020 minus 2013 is 7, so that is 14. That's why we add 14 minutes. So therefore the variation is equals to 1 degrees and 29 minutes west. So again, in your e-plans, don't forget to put the calculations here in your, you can put it here in your chart, or you can I prefer you put it here in your e-plans. Okay, so going back, we completed this task. Next one is identify the deviation using the table. So remember this, that we are 335 ship's course. we go to the table. So this is, so 335 is between 330 and 340, and the 330 is 3 degrees and 340 is 4 degrees. So in that case, it means that 335 is between the two. So because it is increasing and obviously it's in between, so what is between 3 and 4 is 3.5. Therefore, deviation is 3.5 degrees west, or you could also say 3 degrees 30 minutes west. Okay, and after that we go to another task, calculate compass error. So of course, by now you already understand that compass error is the combination of both variation and deviation. You maybe already heard that in previous discussion or in the book. So therefore, we add variation and deviation. So in this case, variation is 1 degrees 29 minutes and the deviation is 3 degrees 30 minutes. So adding the two, we have 4 degrees and 59 minutes. Same name because both are west. So this is the compass error as illustrated. Then the next task is calculate the true bearing. So in order to calculate the true bearing, we need to understand, I advise you to, if you're not still familiar with the computation, or if you missed the discussion, I advise you to refresh in reading the contents in week 1 and 2, or another useful way is to read this terrestrial navigation. Here, download and go to page 90. So the problem is almost the same, and this is how you calculate. As I mentioned before, going compass to true is Candidman vote twice at election, and true to compass is true virgins make the company add whiskey. So in this case, we're finding the true. That's why we use Candidman vote twice at election. So almost the same here, the concept. So given that we have the compass bearing of, as stated before, 345. So 345, and we go Candidman vote twice. The deviation is 3.5 degrees west. So since it is west, so therefore we need to subtract. So we can say that the magnetic is 341.5 or 341 degrees 30 minutes. Next one is variation, which is the variation is 1 degrees 29 minutes. So 1 degrees 29 minutes. So because it is also west, so we subtract, therefore we arrive at 340 degrees and 1 minute. Or for easy plotting or easy calculation, we can say 340 degrees. So therefore, this will be your true bearing, 340 degrees. So now that we have the true bearing, which is 340 degrees, we need to plot it on the chart because that is the final requirement in the Eplan. And we put 340 in transit with these 2 points, so we put here, and afterwards we label accordingly through bearing 340 at 1200. So finally, this is the task. This would what will look like in your chart, only that in your end you must label it accordingly, and this will be calculations that I want to see in your e-plans. So again, in summary, the concept is almost the same in other e-plans, only this time you calculate by bearing the condensed both twice, and for the reference, you can refer to this book, and basically that's all. And if you have any questions, you can always ask me. Thank you.